Hi, I'm Soorya. I'm the coder and project leader of our project. In this role, I focused on integrating wine data and various functions along the way in order to refine our approach. By balancing leadership along with technical coding, I ensured that our AI model effectively classified the wine qualities as good or bad. I also coordinated the team, aligning our efforts to achieve the project goals as well as to enhance collaboration.
Hi, I'm Varughese. I'm the tester and information researcher of this project. I work closely with the users to test prototypes and gather feedback to create actions, plan and address issues related to the project. I gather team questions, identify sources of answers, and compile detailed reports, ensuring all information is passed to the project, reported to effective project updates.
Hi, my name is Varughese and I am the video producer and designer of this wine quality classification project. I work with the team and the users to design a clear process flow for the new user experience. I collaborate to structure workflows that align with our project's goal. Additionally, I film the team's activity and edit them into a video, ensuring that our efforts are effectively documented and showcased for submission.
Hi, my name is Mathew and I am the data expert and communication leader of wine quality production project. And as a data expert and communication leader, I manage and analyze project data to ensure relevance. I lead them discussions facilitating clear communication and goal alignment. Additionally, I document our progress on the logbook, effectively conveying our findings and efforts to stakeholders for submission and feedback.
So this is our wine quality classification program. Here we firstly take the dataset from Kaggle. It's called the wine quality red CSV file. It has been mounted from Google Drive as you can see here. Now we import the modules. Pandas is used to read CSV files and to create data frames. Seaborn is used to create graphs and heat maps. Matplotlib is used to create figures and graphs. Train to split is used to split our data into training and testing data. Random forest classifier is the model we use to train and to create predictions. And classification report and accuracy score are general statistic modules that we'll use to assess how well our model performs. So firstly, we read the CSV file by giving a proper file path to our dataset, and then we can see its columns. So it includes stuff like fixed acidity, ultra acidity, and so on until quality. Then we can see the head values from 0 to 50 and from 50 to 100. So we see the first 5 rows, so 0 to 5 and 50 to 100. So we can see that columns such as volatile acidity, citric acid, chlorides, density and sulfates are always float data types from 0 to 1, so they're all decimals. And now if we print the shape, we can see that there are 1599 rows and 12 columns of this data frame. So if we use the .info method, we can see that every column except for quality is of the float data type, and they are all non-null in every 1599 instances that is there. Whereas quality is also non-null, however, it's always an integer data type, so it's always a fixed number. Now we can see how many of each quality is present by using a count plot, and we can see that most of the qualities are either 5, 6 or a little bit of 7, and then it fizzles out at 4, 3 and 8. And now we can print a bar plot to see how it's correlated. So quality and fixed acidity are what we'll check first. So you can see that first goes down, then slowly shoots back up, and then again goes down. So we can't make a proper judgment. So we can do so with other parameters as well. However, it will take a long time, and to keep it concise, we'll use the seaborne heat map. So by creating a correlation data and by plotting a heat map, we can see that something from 0 to 1 is directly correlated, and from 0 to minus 0.6 is inversely correlated. So greater the positivity, the greater the direct correlation. So we can say that quality is more dependent on something like alcohol, and lower the volatile acidity, greater the quality. So now we can pre-process our data. So we're setting everything in our wine data except for quality into a separate variable called independent parameters. So these are all the parameters on which quality depends. And now we can do the same. However, we set quality to a separate variable called qual, and this is what is dependent on all these previously mentioned parameters. And here we're going to map it such that anything less than 7 is of bad quality and anything greater than 7 is good quality. And so by doing that, we can say that 1382 wines are of bad quality and 217 are of good quality. Now we can split the data using train test split and giving a 0.1 test size, so we get 160 rows of testing, and you can give a random state to ensure that it's reproduced always at the same situation. Now we use the random forest classifier. It's similar to decision tree classifier, however it's multiple of them joined together in order to create outputs, and the mean of them is taken. So we first feed it with the values of independent train, and we also give the quality train variable. So from this, it creates a model, and then we pass the independent test values and we compare it along with the quality test that we have. So by doing so, we get a classification report and accuracy score, and we can say that has an accuracy score of 0.93, which is pretty good. So now we create the user interface. So here the user inputs various statistics in order to see whether the wine quality is good or bad. So here's an example from one of the wine quality rows from our dataset, and we can say that something with these characteristics is going to have a bad wine quality, whereas another row from a dataset which is different might be of good quality. So that's our program. Thank you very much.